Hi, welcome to the Earth Layers Lesson Number 1 reading. The 4 layers. The Earth is composed of 4 different layers. Many geologists believe that as the Earth cooled, the heavier, denser materials sank to the center and the lighter materials rose to the top. Because of this, the crust is made of the lightest materials, rock, basalt, and granites, and the core consists of heavy metals, nickel, and iron. The crust is the layer that you live on, and it is the most widely studied and understood. The mantle is much hotter and has the ability to flow. The outer and inner cores are hotter still, with pressures so great that you would be squeezed into a ball smaller than a marble if you were to go to the center of the Earth. Here you have a diagram of the 4 layers, crust, the mantle, which is divided into upper and lower mantle here, the outer core and the inner core. Take a moment to study this diagram. And as you're studying it, what does it make you think or wonder? If you need more time to study the diagram, please pause the video. The crust. The Earth's crust is like the skin of an apple. It is very thin in comparison to the other 3 layers. The crust is only about 3 to 5 miles or 8 kilometers thick under the oceans, oceanic crust, and about 25 miles or 32 kilometers thick under the continents, continental crust. The temperatures of the crust vary from air temperature on the top to about 1600 degrees Fahrenheit, 807 degrees Celsius. In the deepest parts of the crust. You can bake a loaf of bread in your oven at 350 degrees Fahrenheit. At 1600 degrees Fahrenheit, rocks begin to melt. Here you have a diagram showing the different thicknesses of the different layers. You'll notice that instead of saying crust here, they have the words oceanic plate and continental plate, which refers to the oceanic crust and continental crust that you just read about. Take a moment to study this diagram. What do you notice, or what does it make you think or wonder? The crust of the Earth is broken into many pieces called plates. The plates float on the soft plastic mantle which is located below the crust. These plates usually move along smoothly, but sometimes they stick and build up pressure. The pressure builds and the rock bends until it snaps. When this occurs, an earthquake is the result. Notice how thin the crust of the Earth is in comparison to the other layers. The 7 continents and ocean plates basically float across the mantle, which is composed of much hotter and denser material. So here you have another diagram showing you the different layers. Again, given what we just read, what do you notice? What does it make you think or wonder? If you need more time to study this diagram, pause the video. The crust is composed of 2 basic rock types, granite and basalt. The continental crust is composed mostly of granite. The oceanic crust consists of volcanic lava rock basalt, called basalt. I'll read that again, sorry. The oceanic crust consists of a volcanic lava rock called basalt. Basaltic rocks of the ocean plates are much denser and heavier than the granite rock of the continental plates. Because of this, the continents ride on the denser oceanic plates. The crust and the upper layer of the mantle together make up a zone of rigid, brittle rock called the lithosphere. The layer below the rigid lithosphere is a zone of asphalt-like consistency called the asthenosphere. The asthenosphere is the part of the mantle that flows and moves the plates of the Earth. Here you have a diagram of the lithosphere, which again, that is the consists of the crust and the upper layer of the mantle. So like the very most top part of the mantle. And that part is hard and brittle. So it's rigid, hard, brittle. That's lithosphere. And lith means rock. So that's the rocky part of the top layers of the earth. The layer below that is a zone of asphalt-like consistency called the asthenosphere. So when they say asphalt-like, asphalt is what they use to pave the roads. It's that sort of dark, rocky type thing that flows when it's hot. So the asthenosphere, you can think of when people are paving the roads and they're pouring that black rock. That's what the asthenosphere is like, and it flows. Take a moment to study this diagram. What do you notice? What does it make you think or wonder? If you need more time to study the diagram, pause the video. Okay, the next section is on the mantle. The mantle. The mantle is the layer located directly under the sema. It is the largest layer of the earth, 1,800 miles thick. The mantle is composed of very hot, dense rock. This layer of rock even flows like asphalt under a heavy weight. This flow is due to great temperature differences from the bottom to the top of the mantle. The movement of the mantle is the reason that the plates of the earth move. The temperature of the mantle varies from 1,600 degrees Fahrenheit at the top to about 4,000 degrees Fahrenheit near the bottom. So again, you have this diagram, and it points out where the mantle is. Take a moment to look at it. Now let's move on to the next section. If you need more time, you can always pause or go back. Convection currents. The mantle is made of much denser, thicker materials. Because of this, the plates float on it like oil floats on water. I'll read that again. The mantle is made of much denser, thicker material. Because of this, the plates float on it like oil floats on water. Many geologists believe that the mantle flows because of convection currents. Convection currents are caused by the very hot material at the deepest part of the mantle, rising, then cooling, sinking again, and then heating, rising and repeating the cycle over and over. The next time you heat anything like soup or pudding in a pan, you can watch the convection currents move in the liquid. When the convection current flows in the mantle, they also move the crust. The crust gets a free ride with these currents. A conveyor belt in a factory moves boxes like the convection current in the mantle moves the plates of the earth. So here we have the diagram. Take a moment to study it, and it points out the convection currents. So what do you notice, and what does it make you think or wonder? All right, if you need more time to study this picture, press pause. Outer core. The outer core of the earth is like a ball of very hot metal, 4,000 degrees Fahrenheit to 9,000 degrees Fahrenheit. The outer core is so hot that the metals in it are all in the liquid state. The outer core is located about 1,800 miles beneath the crust and is about 1,400 miles thick. The outer core is composed of the melted metals nickel and iron. All right, here we have the diagram for that. So take a moment to study that. What do you notice? What does it make you think or wonder? If you need more time to study the diagram, please pause the video. Now we're on our last layer, the inner core. The inner core of the earth has temperatures and pressures so great that the metals are squeezed together and are not able to move about like a liquid. but are forced to vibrate in place as a solid. The inner core begins about 4,000 miles beneath the crust and is about 800 miles thick. The temperatures may reach 9,000 degrees Fahrenheit, and the pressures are 45 million pounds per square inch. This is 3 million times the air pressure on you at sea level. So here we have the diagram of the inner core. You need to take a moment to see that. What do you notice? What does it make you think or wonder? Okay, so this is the reading, and what you're going to do now is you're going to answer the post-reading questions. I hope you found this video helpful. Have a quality day. And one final thing I forgot to mention, if there's a section that you need more time to process or was a little confusing to you, feel free to either rewind to that section in the video or to reread that section on your own. All right, have a quality day.